Welcome to this video on the topic of indices. In this video, we're going to have a look at the index law around multiplication of expressions containing common bases. Now, the law that we look at is defined as a to the power of m multiplied by a to the power of n can be simplified down to a to the power of m plus n. So what you're doing here is you're grabbing these two exponents and you add them together. So factors of common bases can be simplified by adding the exponents together. So we've got a common base a, and we simply grab exponent m and we add those two together to yield our result. Now that we've had a look at this rule here, let's have a look at some examples. So we want to simplify. In example 1, we have 2 to the power of 2 multiplied by 2 to the power of 3. So what we're first going to do is we're just going to apply the rule. So we've got exponent 2 and exponent 3 and a common base of 2. So we're simply going to grab our 2 like so. Then we'll go 2 plus 3. This will yield a result of 2 to the power of 5. Now, in the previous videos, we would have got to this step and put it in our calculator and got our result. But this one says simplify, so I'm just going to leave it as 2 to the power of 5. But now that we can apply this rule, let's have a think, why does it work? And the easiest way to do it is let's go 2 times 2. And then we'll go 2 times 2. And what we're going to have here is the first 2's we have over here. They correspond to this guy here. And then the second lot of 2's, we have 3 of them over here. So what we find is that if we count the number of 2's we have here, it's going to be a total of 5. So that agrees with the result we get down here, 2 to the power of 5. So that's example 1. Now example 2, we attempt to apply this rule in an expression containing algebra. So our base in this case is x. So we've got x to the power of 4 multiplied by x to the power of 3. We're going to tackle this example the same way in which we tackled this example up here. What we're going to do is we're going to get our common base of x, then we're going to get our first and our second exponents, and we're simply going to add those together. So 4 plus 3. This will yield a result of x to the power of 7. So the simplification of x to the 4 times x to the 3 is x to the 7. But you probably remember this from your algebra laws. Alright, moving down. We have example 3. 5 to the power of 5 multiplied by 5 to the power of negative 4. So where the difference in this example comes from is we have a negative 4. In which case, we're simply going to treat this as if it's a positive number, but with a negative in front. So what we're going to find is that our common base is 5, and our first exponent is 5, and then we're going to add minus 4. Now this is going to be simplified down to 5 to the power of 1. Now because this is to the power of 1, we can simply rewrite it as 5 because an exponent of 1 is implied. Okay, now example 4, we have x squared times y cubed times x cubed times y to the negative 2. So what we're dealing with here is an example where we have different bases multiplied together. So we've got x's and we've got y's. What we're going to do is we're going to get the exponents for the x's, so 2 and 3, and we're going to put those above the x. So we'll go 2 plus 3. Now we're going to go back and we're going to grab our y's. So we're going to get exponent of 3 and minus 2. We're going to add those guys together as well. For these sort of questions, we do not ever mix the exponents of different bases. So never mix exponents of differing bases. Now simplifying this out, x to the power of 2 plus 3 is x to the 5. and y to the power of 3 plus minus 2 is going to be 1. And then that can be simplified further as x to the 5 times y, because the 1 is implied. So this is a simplification containing a algebraic expression whereby we have different bases. Okay, example 5 now. We have 2 to the power of 3 times 2 to the power of n. So the difference is we have an unknown in our exponent. Now we simply treat this example like we've treated every other example in these set of examples here. So we're going to get our common base of 2. Then we're going to go 3 plus n. And because we can't add 3 and n together, this is as far as we take it. So this has been a video demonstrating how we can apply the index law pertaining around the multiplication of common bases to simplify some numerical expressions and some algebraic expressions.